Hi everybody. In this Physics 112 video, we are going to cover the topics from week 7, which are inclusive of electromagnetic waves and the electromagnetic spectrum and reflection. And then afterwards, we're going to cover an MCAT-like question on these concepts. So the first concept that we're going to cover is electromagnetic waves. And the first thing that you need to know about electromagnetic waves are they are generated from an accelerating electric charge, meaning that an electric charge that is oscillating or vibrating has the ability to generate these electromagnetic waves, which are composed of oscillations of both electric and magnetic fields. And these electric and magnetic fields are perpendicular to each other, as well as perpendicular to the direction of propagation. So these electromagnetic waves are self-propagating, meaning that when you consider an electric charge that is accelerating, meaning it is changing direction or changing speed, that will induce a changing electric field because it's constantly accelerating. So when you have a changing electric field, that's going to induce a changing magnetic field. And these magnetic fields are going to be perpendicular to the changing electric fields. And since the changing magnetic field has the capability to produce a changing electric field, that's how an electromagnetic wave can self-propagate itself. And so these changing electric fields and changing magnetic fields, as you can see by the diagram, produce the electromagnetic waves. And the electromagnetic waves have a few characteristics about themselves, which are displayed in the diagram. So these electromagnetic waves are transverse waves, meaning they vibrate at a right angle to the direction of propagation. So as you can see by this diagram right here, we have a B field, which is in red, and an electric field, which is in blue. And the B field and electric field are perpendicular to each other, as well as to the direction of the velocity v, which is demonstrative of how the electromagnetic wave travels. And so an electromagnetic wave can travel in both a medium and a vacuum. So we're going to talk about in another video how the speed of an electromagnetic wave changes in a medium, whereas in a vacuum, the electromagnetic wave travels at a constant speed, which is denoted by the letter c. And so the value for c, or which is just the speed of light in a vacuum, is 3 times 10 to the 8th meters per second. So you should know that all waves travel at this speed in a vacuum, regardless of their frequency. So if you ever see a question that asks you, for example, what is the difference between the speed of red light versus the speed of blue light in a vacuum, you should know that these speeds do not differ. So now that we're talking about speed and velocity, here's the equation for waves, which is velocity is equal to wavelength times frequency. And this is a very important equation because you'll have to definitely apply it in different situations. And you should also know that the equation is built to calculate for meters per second. So that means that you should use meters for lambda or wavelength, and then hertz for frequency. And hertz is just equal to the inverse of seconds. So when you multiply the wavelength in meters times the frequency in the inverse of seconds, then you'll get meters per second. So be sure to convert your units to meters and seconds. So the next thing that we're going to talk about is the electromagnetic spectrum. And the electromagnetic spectrum is important because the frequencies for electromagnetic waves span a huge range, meaning that each type of electromagnetic wave has a different wavelength and a different frequency. And so as you can see in this diagram, the longer the wavelength, the lower the frequency and the lower the energy. And you can also see how we can denote this from this equation. E is equal to hf, where h is the Planck's constant and frequency is the frequency of the wave. We can see that frequency is directly proportional to energy. So that's why there's a higher energy and a higher frequency on the left side of this electromagnetic spectrum, whereas the longer wavelength has a lower frequency and lower energy, because this equation can be further displayed as E is equal to h times c over wavelength. So what you should also take away from this electromagnetic spectrum is at the very center is the visible light spectrum, and this is all the light that we can see as humans. And so the visible light spectrum works that on the left side there is a higher frequency and thus a lower wavelength. So opposite of that is the right side has a larger wavelength and a lower frequency. So the visible light spectrum is made up of all the colors that you'll see in the rainbow. And then I like to consider this as the visible light spectrum is a backwards rainbow, meaning that the violet on the left side has a longer frequency, and then the red light on the right side has a longer wavelength. So these are inversely proportional to each other, wavelength and frequency. So the next topic that we're going to get into is reflection. And so the law of reflection is essentially what you really need to know for this concept. And this states that when a ray of light passing from one medium is reflected from the surface of another, the angle at which it bounces off the new medium is equal to the angle at which it strikes. So if this doesn't really make a whole lot of sense just because it's too many words, then you should just know that the angle of incidence is equal to the angle of reflection. And by the angle of incidence, we mean that the angle between the ray of light and the normal from the surface. So this is very important because you might get a question like below that asks you, assume in the figure above, the ray of sunlight strikes the mirror, making an angle of 60 degrees with the surface. So what is the angle of reflection? So I'll give you a moment to answer that question. You can pause the video, and then if you want to get the answer, then I'll just go ahead and continue. So the answer is 30 degrees. So like I was saying before, the angle of incidence and angle of reflection are measured with the normal. So in the question it asks us, what is the angle of reflection? But it gives us the angle between the reflected, or it gives us the angle between the ray and the surface. So we need to subtract 90 degrees, so we can get we need to subtract the 60 degrees from the 90 degrees to get the angle between the ray and the normal. So that's why the incident angle would be 30 degrees, making the reflected ray 30 degrees also, because the angle of incidence and angle of reflection are equal to each other. So lastly, we are going to cover an MCAT-like question from the concepts above. The question reads, a spectroscope is a device for determining the composition of incandescent objects. In one design, light enters a spectroscope and passes through a diffraction grating, producing a pattern of spectral lines at frequencies characteristic of the elements in the source. If the Earth is moving towards an alien who is standing on a distant planet and studying it with a spectroscope, which of the following statements is true? So go ahead and read the statements below and answer the question. And then if you'd like to solve this problem, just go ahead and pause the video and then we'll provide the answer shortly. So the answer from the choices above is A. So if we look at option A, it reads, observed spectral lines in the light emitted from the Earth are shifted toward the blue end of the visible spectrum. So if we consider a topic that we learned back in Physics 111, which is Doppler effect, then we know that a change in frequency of the light will occur as the object moves either closer or further away from the observer. So when the object in question, which is the Earth, moves towards the alien on the distant planet, the frequency of the light emitted from the Earth will increase, resulting in a light that shifts towards the end of the visible spectrum with higher frequency. So when we consider the visible spectrum, we know that blue and violet is on the left end of the visible spectrum, meaning it has a higher frequency. So since the frequency is perceivably increasing, the light will shift towards the blue side, since blue has a higher frequency than red. So if you have any other questions, feel free to leave them in the comment section below.